In this video, we're going to be deriving the formula for projectile motion in the case whereby the object is projected from the ground level to ground level. That's the point where it is projected from this point known as point O to this point on same plane of ground level. We're going to be considering 4 parameters. The first one is the maximum height. The second one is the range. The third one is the time to reach this maximum height. And then the fourth one is the total time of flight. That's the time it takes this object to travel from this point O, follow this curve, and then land at this point here. So we're going to start with the maximum height. Now let's record this formula of motion. V square is equals to U square plus 2AS. Now this initial velocity here in this case is inclined to an angle theta, and because it is inclined to this angle, we're going to resolve it to its vertical and horizontal components. Now the horizontal component of this velocity, which is ux, is equals to u cosine theta, and then the vertical component, which is uy, is equals to u sine theta. In this case, we're going to be making use of the vertical component of this velocity because that is what determines the maximum height, the range, and the time of flight of this projectile. Now let me write this question as v square y is equals to uy square plus 2. Now this acceleration, remember this projectile motion is influenced by the gravitational force. So this acceleration here is going to be equals to negative g because it is projected upwards, which is against the gravitational force. So we're going to replace this a with negative g, right? And then this s, which is displacement, we're going to be replacing it with height, which is this height. Now coming to this v square y, at maximum height, this v square y is equals to 0. This will be equals to this u square y is going to be the vertical component of this initial velocity, which is u sine theta. So we're going to be replacing u square y with u sine theta all square. Then this plus times minus is going to be equals to minus 2. We have gh. Now let's add 2gh to both sides. This and this will cancel. We'll be left with 2gh is equals to, now this u sine theta square is equals to u square multiplied by sine theta square is equals to sine square theta. That is sine theta times sine theta is equals to sine square theta. So since we're looking for h, let's divide both sides by 2g. This and this will cancel. We have that the maximum height is equals to u square sine square theta divided by 2g. And so this is how the formula for maximum height in this case was derived. Now let's derive the formula for range. But before that, we're going to derive the formula for time of flight and then total time of flight. Now for time of flight, we make use of this formula. V is equals to u plus at. Now let's rewrite this as vy is equals to uy. Remember, we're making use of the vertical components of all these velocities. So plus this a, we're going to replace it with negative g, then multiply by t. So at this initial time here, final velocity is going to be equals to 0. Now this will be equals to uy is going to be, we're going to replace it with u sine theta, then plus times minus is minus g times t. So let's add gt to both sides. We're going to have that gt is equals to u sine theta. So let's divide both sides by g. and then this and this will go. We'll be left with, we have that our t, which is the time to reach this maximum height from this point to this point, is going to be equals to u sine theta divided by g. Now you know that the time it took this object to reach from here to here is equals to the time it take it to travel from this point to this point. So invariably, the total time of flight, which is this capital letter T, is going to be equals to 2 multiplied by this small letter t, which is equals to u sine theta divided by g. Alright, but how do we derive this formula from the equations of motion? So let's do that. Remember, all of these formulas are based on this case from ground level to ground level. That's from this point to this point on same plane. So let's use this formula. S is equals to ut plus half at square. So we can write this formula as y, because we are dealing with vertical component of velocity and also vertical distance. So y here is equals to this here, we're going to write it as u y multiplied by t plus half at square. So this y here is 0, right? So we have 0 is equals to this uy, which is the vertical component of the velocity, is equals to u sine theta multiplied by time. Now this a is going to be equals to negative g, and then plus times minus g is going to be minus, so we write minus half gt square. So we have t here and we have t square here. Let's factor it out, but then let me rearrange this first. We have u sine theta multiplied by t minus half gt square equals to 0. So let's factor out t. If we factor out t, we'll be left with u sine theta here, and then minus half gt, then this will be equals to 0. So you have that t is equals to 0, or u sine theta minus half gt is equals to 0. Now at this point, is this t equals to 0 is at this point of projection. So at this initial stage, the time is equals to 0. Alright, so let's take this, let's add half to both sides. So let's add half gt to both sides. We have half gt here, so that this and this will cancel. We'll be left with u sine theta equals to half gt. So let's multiply both sides by 2. We're going to have 2 multiplied by u sine theta is equals to half times gt multiplied by 2. Now these 2 and these 2 here will cancel. We'll be left with 2u sine theta equals to gt. Now let's divide both sides by g. This and this will cancel. Then we'll be left with t is equals to 2u sine theta divided by g. So let's just replace this t with t, capital T. So this is how the time of flight is gotten, 2u sine theta divided by g. So we are going to now find the range. Let's derive the formula for the range. So range, remember the one of the equation, we have that velocity is equals to distance over time. So this velocity here, we're going to be making use of the horizontal component of this velocity, because that determines the range. Okay, so we have vx is equals to, now this d here is the range, the distance, so we replace this d with r, then divided by t. Alright, now we have u cosine theta is equals to r divided by t. So let's multiply t to both sides. We have this and this will cancel. We have that range is equals to u cos theta multiplied by t. Alright, now this t here is the total time of flight, which we have found earlier to be 2u sin theta divided by g. So we're going to replace this t with this. So we have range is equals to u cos theta multiplied by 2u sin theta divided by g. Then you know that, let me just swipe this upper part. So we have that range is equals to u times u here is going to give us u square, and then in trigonometry 2 times sin theta times cos theta is equals to sin 2 theta. Then we have divided by this g here. So this happens to be the formula for range of a projectile. Initially I told you that the vertical component of this velocity is what determines the maximum height, the range, and the time of flight of this projectile. But then it happens that the horizontal component of this velocity also contributes to the range, as you can see in this derivation of the equation for range. So both the vertical component of the velocity and the horizontal component determines the range of a projectile, in this case from ground level to ground level. So thank you for watching. Please feel free to subscribe to my YouTube channel, like this video, and share with your friends. Don't forget to drop your comments. Have a nice day.